Okay, so we are still talking about the tools we're going to need. Vectors was one, and scalars, and so we are basically talking about right here the tools and things we should know before we do anything. Okay, so this is really, we're talking about all the tools we'll need. Okay, and so far we talked about vectors, we talked about scalars, we talked about what that symbol meant, but I also talked about in class about other symbols and units. And I said these are very important tools for your whole high school career, understanding the difference between symbols and units. So let's talk a little bit about that. We talked about it a lot in class, and you know there are charts up on the wall that you can see that explain the difference. Now we said, here's what we said in class. We had names of different items, and it's still up on the wall, and I'll get you a copy of that sheet as well. But let's make sure we have a column that says, hey, here's what the item really is that we're going to be talking about right now. Here is the symbol for that, because no one wants to keep writing out the full name. And here are the units. Okay, now let's start off with units first. Units describe the number in front. Well, actually, let's go back and name some of these. The name, the symbols, and the units. Then we'll explain where they're used. Let's talk about velocity first. Velocity. Now, we don't want to keep writing out this whole word, so we're going to use for a symbol a V. Can't use the same symbol twice, so we're using the V now. Capital V, that is, we're going to use. So we won't be able to use it again, but now we know when we see a capital V that it means velocity. But what is velocity measured in? Now we're going to be using SI units of measurement, the System International. So we're going to be talking about velocity measured in something called meters, which we'll get to in a second, per second. That's the units. What that means is if you see a number, and I'll use something right now you're a little more familiar with. In your car, you have this thing called a speedometer. Now, it's called a speedometer, not a velocimeter, because velocity measures magnitude and distance, magnitude and direction, but the speedometer only tells us how fast we're going, only the speed. So here is this thing, and it is a speedometer, and it measures speed. And we're going to give it a value for that speed, and we're going to say that speed right now is, let's say it's 55 miles per hour. Okay, we are doing 55 miles per hour. 55. And 55, if I just said to you, walked into class and said, today we're going to think about something, I want you to really think about this, 55, you wouldn't know what I'm talking about, would you? But if I said, I want to talk about this thing, this, this value, and it's 55 miles per hour, that's the American units now I'm using just because I figured you'd be more familiar with it, you would know I'm talking about a speed. The speed that most highways have as their max speed, 55 miles per hour. You know exactly what I'm talking about. Well, here's the point. The point is that the 55 miles per hour are units. This part over here is the units. And it tells you what the number in front means. It means that I'm talking about miles per hour. It is a velocity or a speed. In this case, it's a speed because there's no direction. Okay, so the units are a name. Let's yellow that out as well. Okay, let's say units are a... This over here is nothing more than a name. It is a name describing what the number in front means. So this is a name. And let's see how it works without it. If I walk into class and I say 90, Joey, 90, what does that mean? You have no idea. But if I say 90% for your grade, now you know. So the percent for your grade is a name. Well, so is this miles per hour. It is a name for 55. So units are nothing more than names that describe the number sitting in front of it. Symbols are letters describing what we're talking about, and they are used in formulas. So, for example, let's put a few more down over here, and then we'll come back and explain the symbols a little bit more. Let's do another one. How about distance? Okay, distance, D, is measured in meters. I'll put it over here so you know it's meters that we're talking about. Time, T, is measured in seconds. Here's one that you probably had in 8th grade, but you may not remember it. Mass. M is measured in grams or kilograms. Okay? Force. F is kilograms meters per second squared. That's a lot to write, so we often, in honor of the man, Newton, use an N for Newton. Okay, let's pause there a second. Oh, one more, because it's motion. Acceleration. Boy, nobody wants to write this whole thing out, so we use the first letter, a little a, and that's measured in meters per second squared. Now, here's the important point. I wanted to point out. Let's take and highlight this so you can see what I'm talking about here. Let's see, where are these highlighters? There they are. I want you to look at this column over here. What letter do you see here? Mass, M. Makes sense, right? But uh-oh, what do you see over here? Another M. How can you tell the difference between these two? Why are there two M's? Well, I'm going to tell you. Here's what we have to find out. Here's what we have to realize. That symbols are only seen and used in one place. Let's write that down. I'll show you. Symbols are used in the formulas. and I said, don't panic when you see this word. Be much better if I spelled it correctly. In the formulas, what's a formula? It is a recipe. It says if you want to find force, and I'll write over here that that's a force, that's a symbol, we have to mix a mass, here's a time sign, times an acceleration. Now you can see how you don't want to write the bottom out all the time, but this formula is a recipe. It says they're going to give you a mass, tell you what the mass is, and they're going to tell you what the acceleration is when we do these. And when you multiply these out, you're going to get a force. So these are symbols, okay? These are symbols, and they're only used here in the formulas. So when you go back and look at, well, I've got a formula here, and you look at what mass is, you're going to see that the mass uses the first letter M. But it's measured in units of kilograms. Okay? Now, for distance, and you saw the meter stick in front of the class, meter sticks are a measure of meters. The units here, the symbols here are D for distance. So we don't have to write out the whole thing. We're finding out how to mix and match and put in the recipe to find what distance is. It's measured in meters. Now, we went over this extensively in class, and you have your chart that shows you the difference. And now you know that units are simply the names of the number in front of it. So if over here I had 10 meters per second, you would know that I am moving at a velocity, because meters per second tells you what it is. It's a velocity. And I'm moving 10 meters, a distance of 10 meters every second. It's a velocity. Okay? Now, we went over this in class, and we did quite a few practice problems with this. And you have your charts that tell you the difference. So I just wanted to let you know that we covered it. Look in your notes to see what they are. Let's do one more over here. Velocity is equal to distance divided by time. All symbols. These are the symbols. Now, if I had a distance, what is this? This is a unit. It stands for meters. The distance is equal to 5 meters. If I'm not sure, I look at my chart, I go up on top, and I say distance. There's the D. Oh, and it's measured in meters. And if I go 5 meters there's my symbol. What does it stand for? The T stands for good, time. If I go 5 meters every 5 S, what are the units? S. What's the symbol? T. There's the formula.